Hello. In this video, we will discuss how to interpret the visual field test output display from the Eyeonic online visual field test system. This is an example of a visual field test performed by a person's right eye, and you can see that their right optic nerve has some glaucoma damage. It's missing some of the rim inferiorly, and also there is a matching defect in the retinal nerve fiber layer inferiorly. And consequently, because they have inferior loss of the retinal nerve fiber, they have a superior visual field defect. But let's unpack this visual field test output and understand what it all means. The first thing to note is that it is a 24-2 test, which means that we're assessing the 24 degrees of central vision. So each of these maps that you see here all represent the visual field out to 24 degrees with the center where the lines meet. So central fixation is right where these vertical and horizontal lines meet. Now, the test was performed on the 14th of February 2024, and it took 3 minutes 31 seconds. Now, the first of these maps to look at is the sensitivity values map. These are the raw scores achieved at each point. Remember that while the user is looking at the central target, ours is a spinning gold star, which is there, each of these points is being assessed for sensitivity, and there are 52 points altogether. And you can see in this individual, in the bottom half, in the inferior half of the field, they're getting a sensitivity of 30 at each point. While in the superior half, some of them are achieving 30, but others are not quite as sensitive. So some of them are at 20, this one's at 12, and this one's at 19. So we can see from looking at this that there is reduced sensitivity in the top half, particularly the top left half here. And that is conveyed in this sensitivity map here, which is an impression of the overall visual field, that there's something missing there. Now, the question you might be wondering is, well, what does 30 mean? Is that normal? Is that abnormal? And that's what this total deviation is about. It's a comparison of these numbers here to the age-matched normal. And this normal is dependent on population. So we have validated our test in different ethnic groups and geographic profiles and tailored it to the differences in each group. So for this individual of this age in this geography, we would expect them to get a sensitivity of 28 at each point. And that's why for all these points, they're +2. This point here actually got 28, and that's 0. While this point here, 19, is 9 less than 28, and so that's why it's -9 there. And so you can see all these numbers here reflect the difference between what they got and what was expected at each of these points. So that's why you can see that deviation, particularly the upper left, is come out. Now, the next thing to say is, well, that's all well and good. Some spots are -5, some are -17, but is that a significant change? Is that an important change, or is that just a random fluctuation? And the answer is found here. So we want to know if each of these deviations is a real significant defect. And that's how we compare it to an age-matched population, again, sensitive to the differences between different geographies and ethnic groups. And you can see that this map shows the answer. So this point here of -17, that really is a significant difference at a significance of less than 0.5%. While this point here at -5 is also significant, but only at 5% significance. So there's a 1 out of 20 chance that this point is reduced just out of a fluctuation, but there's a 1 out of 200 chance that this point is reduced purely out of fluctuation. These 2 points up here, -2, -3, that difference is so minor that it did not even achieve significance. So that explains this map here. Now, what's the difference between the total deviation and the pattern deviation? Often in visual field testing, there is a global defect. Just say someone is wearing the wrong power glasses, or someone has a media opacity like a cataract. And we're not interested in that in glaucoma. We're not interested in global defects. We want to know the focal defect. And that's why, moving from total deviation to pattern deviation, we subtract out all the global defects. And that's global change is actually a -2. So you can see all these points here are 2 above what we expect. They've moved to 0, while the point that was -16 has moved to -18, and the point that was -2 has moved to -4. And then we ask the same question again, is that difference significant? And you can see that now that these negative points are a bit larger, a few more have achieved significance, such as this point here, which was -3, has now become -5, and that's reached significance at the -5, less than 5%. Now, to the trained specialist who looks at these day in, day out, this is the first map that you look at, the most important map, the pattern deviation map, which tells us if there's a focal defect. To summarize these scores of these numbers, so the visual index is 94%, which means that this person has overall lost 6% of their vision, and that's what corresponds to here. And the mean deviation is a average of all of these spots here, and you can see it's only mildly reduced at -0.1% because this defect is relatively small, while the pattern standard deviation looks at this map here and looks at how much of a focal defect there is. So because there is a difference between these points and the others, that has come up with a larger pattern standard deviation of 4.7, which has reached significance. Very important are these 3 numbers here. These are the reliability criteria: fixation loss, false positive, and false negative, and they give an impression of how reliably the test was done. Now you can see here that this person, their fixation was tested 8 times, but only 1 time was the fixation slipped from the rotating gold star. So that's a good test. False positives are when they click when a target is not presented, and that's only 9%, while false negatives, which is when they don't click, when we know that they should be able to see it based on previous results, and that's at 0%. So these proportions are low, and that's why it's a good test. If any of these proportions were high, there would be a pop-up here saying test results are unreliable. That doesn't mean you should throw out the test. Often you can get some meaningful output from a test that's been labeled unreliable, but it just means that the reliability criteria are not as high as we like. And finally, we perform an overall statistic of the tests, looking at the differences between top and bottom. And if there are differences, the test will show outside normal limits, while if it's a normal test, it will say normal. So this person has a superior defect in the nasal area. Now, the next question is this getting worse? And that's what this progression analysis shows. So on this change analysis, you can see that they have 2 baseline tests, both on the same day. And then we have performed a number of tests in quite short period over time. And this is their most recent test. And comparing the baseline 2 tests, these are the pattern deviations, to the most current test, there are a few more points, and some of these points are more deeply affected than before. And that's why these blue dots have come up here. This is the change from baseline. So this map here represents which points have actually gotten worse, whether only on 1 test or on 2 tests or on 3 tests. And because there have been a few points getting worse, but not a huge number, it says possible progression. Now, is the visual index, which is the overall percentage reflection of the test, is that getting worse over time? The first 2 tests were 98%, 96%, and most recent one, 94%. And potentially, yes, as mentioned before, there are random fluctuations in visual field testing because it is a subjective test, so it's not as precise as an anatomical scan. But the question is that change significant? And because there has been a slight deviation over such a small period of time, we have found that it is deteriorating at a rate of 11% per annum with a P of less than 2%. So potentially this person is getting worse. Thank you for your attention. And if you have any questions, please let us know at inquiries@eyeonic.com.